Okay, the ratio test. The ratio test is a useful test for the convergence and divergence of a series, particularly when the series contains n factorial or has n as an exponent. In this case, we see n as an exponent. Now, one thing that you notice, a lot of series can be solved with multiple tests. For example, this, if you use it as a geometric series, it would have a ratio of 5. R is equal to 5, which is greater than 1, so that diverges by the geometric series. But now, just say if you forgot the geometric series rules, we can use another test. So in this case, we will use the ratio test. So now, this is what we would do in this case. All right, we would say 5 to the n plus 1 over 3 over the original series. All right. The only thing we did first was we replaced n with n plus 1. Now, we need to establish our rules. That's, the limit as n goes to infinity. You remember from the old rules that you learned as a child, when you divide by a fraction, you multiply by the reciprocal. All right, so now we have 5 to the n plus 1 over 3 times 3 over 5 to the n. Of course, the 3's will cancel. 5 to the n plus 1 over 5 to the n, that cancels all the time to 5. Remember, if you put a 0 in, that would be 5 over 1, which is 5. If you put a 1 in for n, 5, 1 plus 1, 5 squared, 25 over 5. 25 over 5 is 5. If you put a 2 in, 5 cubed, 5, 2 plus 1, 5 cubed, 125 over 25. That will still give you 5. So now I'm coming back. The limit is 5, which is greater than 1. So therefore, by the ratio test, the series diverges, which we already knew it diverged by the geometric series, but this is also a good way to check your answers to make sure that you're doing everything correctly. All right, so that's the ratio test. It's a very easy, quick test. You are going to have to go back and remember some of your algebra rules, but that's pretty much everything in calculus. All right, so we have this one. Now I want us to look at one that contains a factorial. Yeah, let's just go. Two to the n over n factorial. All right, 2 to the n over n factorial. Now, what do we do in this case? We let our limit goes to infinity, and everywhere we see an n, we replace it with n plus 1. That's 2 to the n plus 1 over n plus 1 factorial over the original series, which was 2 to the n over n factorial. Once again, when we divide by a fraction, we multiply by the reciprocals. Those rules do not change. So now we have 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. Now, this is a little bit different. Now, if you remember, just like the problem we just did, 2 to the n plus 1 over 2 to the n, that's going to automatically, we know, give you a 2. All right? Now, you have to go back and review your factorial rules. Remember, 4 factorial is 4 times 3 times 2 times 1, moving downward. 7 factorial is the same. 7 times 6 times 5 times 4 times 3 times 2 times 1. N plus 1 factorial and n factorial. That's just going to leave you 2 over n plus 1. Now, I'm coming down another row for space. And if we remember, now we have to remember our rules as a sequence. 2 over n plus 1. The degree is higher in the denominator, so that was equal to 0. 0 is less than 1, therefore our series converges. So that's just a good example of the ratio test. Of course, there's other ones, but those are the very 2 basic fundamental type of problems from the ratio test. Everything else kind of piggybacks off of that, but these are the good established basic problems that we have.